All right, so yesterday I released your lab number 1 solution video. So that one there is optional. So if you really want to somehow see how to develop the solution from scratch, you are more than welcome to follow the video. It's really creative for you. But if you just want to look at only certain parts, go under the description on the YouTube. There's a timestamp for you. Just click on the part you want, okay? And then lab number 2 is also released. You got 5 labs in total for this semester. I would say lab number 2 and lab number 4 might be the most challenging one. Lab number 3 will be quite an easy walk, I would say. That's going to be released shortly after the reading week. That one there will give you a little bit breather, okay, just to get a bit easier. But, you know, just do the lab number 2. I'm pretty sure you'll learn a lot, especially about exceptions and also using the arrays. And for your programming test 1, that's going to happen next Wednesday. So as I said, there will be a review session tomorrow, 2 p.m., and also in the Curtis Lecture Hall. I think tentatively we can run for about maybe 18 minutes or so. But if you guys got questions, or maybe if we really have to run through everything, like every part of the solution with you, we're more than happy to stay up to 2 hours. And myself, I'll be there. If you want to ask me questions after the session, I'm more than happy to stay as well. So please come by, join us, and then ask questions. I will not be hosting the session myself, but there will be a former student taking the course. So she's going to hold the session. But it's going to be very good. I'll be there as well, just in case you got any questions. But it's going to be worth your time. Please come. All right, any questions? And for your programming test 0, you might be wondering, we started the grading process, but it's still ongoing. I'll keep you posted, okay? And then I'll let you know. I should be able to let you know a little bit more concretely on Monday, okay? We'll definitely already started the process, but it may take some time. All right, recap. And then today we're going to do quite a bit of tracing as well in the first part. Oh, sorry, not this part here. Beg your pardon. Sorry about that. Let me just get rid of that one here. All right. So last time we actually spoke about the version 1, 2, and 3. So that one there, I will need to rely on you to really study into the details. But I would say when you study the 3 versions, number 1, study just on the paper to see what the differences are between the 3 versions. Each one of them illustrates some valid programming solution. Number 2, you also want to do the tracing on the paper as well, right? Which I did for version 1 thoroughly. And also, you may also want to try use a breakpoint in debugger to really trace through what's happening in different input cases. And when we get to the new lecture today, which I'll give you some introduction today in the second half, we also need to exploit the execution flow. Okay, I'm going to review a bit also today in the final part for the exception lecture. So please review about the 3 versions, and do let me know if you got any questions about the 3 versions, right? So I'll lead you to see the detail. I know I still owe you the recording from Tuesday's class. I'll make sure I post them either tonight or tomorrow morning for sure. You can definitely review if you need to. Okay, so this diagram here is also very important. We generalize this, about the stack, about how when you got a chain of method call, we assume that at the very last one, which is the cost for the stack not to really grow any further, you got some exception thrown from there. So for this very top method here, in principle, we'll just let it specify. Okay, we don't really catch it at the same time. From there, you got catch with specify, catch with specify, etc. So we assume that at some point in the middle, I'm not sure how low it is, just say at some point, some method will choose to catch it. And then beyond that point, we are going to be free from the catch with specify requirements. Yes, question?
I have a question about version 3.
Sure, you may.
So it mentions how it propagates the exception towards the console.
Yeah.
So if we trigger an exception and it's sent to the console, is it not handled? Like, do we just...
Good question. So Patricia's question goes like this. Let's say for version 3, let's see what version 3 did. Exception was basically originated from here. Somehow every caller along the way, including the entry point of execution, every one of them chooses to propagate the exception further. At the very last call in the stack, entry point of execution, if that one also chooses to specify, that means this exception here will just be thrown to the console. As soon as it's thrown to the console, it's really there. There's no way for you to somehow to say, oh, I want to pause it and then handle that. No, nobody can handle that anymore.
So does the rest of it not execute? Does the rest of it not execute? Does it stop at the console?
Yeah, it will just be thrown to the console, yes. You can think about that's really the final outcome for this particular execution run. So nobody actually chooses to catch that.
diagram that says method call and then method call. So
Yeah.
does that happen first?
Right. Think about the sequence goes like this. This entry point of execution calls this method. And this method here calls this method. And then this method here somehow throws that exception. And it throws that exception to its caller right here. And this caller here chooses to propagate that further. It doesn't catch that. So this will be propagated to the next caller. And this caller here also chooses to throw it away, also propagate it. So when this is propagated actually further, there's no further caller except for the very first user who actually launched the main method as a Java application. So now when this is thrown to the user, there's nothing we can do really. The exception is simply there. All you can do is maybe take a look at maybe some detail of the textual detail of the exception in the console, and then maybe try another run.
So in the upper versions, we chose to handle the exception. So when that happens and we handle an exception, does it like resume the method call or?
Okay, you're saying maybe like a version 2, for example, right? Like okay. Good question here. So let's say version 1. That might be a little bit easier. So let's say this method here chooses to propagate the exception to here. And then let's say this method here chooses to catch that. So once it catches that, that means the catch block is going to execute some lines of code. So all the execution will go from there. It depends on how exactly you set up the catch block. The catch block, for example, might actually call other method. That method may throw some other exception. So this might just keep going in general, right? So the principle is you want to make sure every time once the catch block actually catches some exception, that particular exception being called is gone. All the rest of the execution flow will just go for the rest of that particular catch block. And that catch block there can just be arbitrary Java code you have to execute.
So the rest of the code is only the code within the catch block?
Yeah, all the code within catch block. And also, let's say, for example, so let's say we have executed everything in the catch block. So what should we go next? In case outside the try and catch block, if you still got more lines of code after that, you still got to execute them, right? Yeah. Okay. So guys, do think about this kind of issue. I think these are important. Do ask me questions. I don't mind being slowed down. Okay, question.
Yeah. So an example in version 3.
Yeah.
Can we not have something in the exception class itself to handle like errors that go to the console or no?
Interesting. You're saying in the exception class itself, you're saying, for example, here, like a negative value exception?
Yes.
Okay. The short answer should be no. Because you think about what's happening here. When all you define in that particular class, in the negative value exception, is you kind of define a constructor about how you can create an object of type negative value exception. But there's no way for you to see, oh, am I right now in the main method? Am I right now in a particular call? There's no mechanism for you to think that way. Yeah. So the only way you can do within your power as a programmer is to say for every method along the way, you got to make sure one method there is going to call a method that might throw the negative value exception. And from there, you may choose to catch it. That would be the only way you can do. Okay. So a little bit of preview of your lab number 2. So the way we're going to set up lab number 2 will be, so there will be a series of exception classes you have to create and also to handle. Right? So do struggle with that a little bit. And then since next Wednesday will be your programming test 1, I'll make sure I schedule some TA hours as well. You can feel free to reach out to the TA by email, and then they can also have some Zoom session with you if you got any question about a lab. Okay, I'll make sure that happens. Also, during the reading week, we can also schedule some hours for you to help you on lab 2. Yeah, question?
So how would the scheduling the TA work? Because the test is on Wednesday, right?
Yeah, so I think we can make it more like on demand. So I'll just need to confirm which TAs are gonna do this. Let's say we may schedule 2 or 3 TAs. They will simply stand by. So you can just email to any one of them to say, okay, can you please maybe Zoom with me for 5 minutes? I have some question about lab 2, something like that.
Cool.
Yeah, we'll make it flexible, yeah.
Just to make sure, are we gonna have exceptions in the test?
Mean programming test 1?
Yeah.
No. Okay.
And one more question about that.
Okay.
How do we really know when to catch the exception?
Okay,
In
good
which
question.
method?
In which method? It's a good question here. So, okay, let me repeat the question. It's an important one. Let's say here we got method 1, method 2, and method 3, right? Which method should really catch the exception Programmatically, you can choose either one of them, even if you want to catch the exception right here when the exception is originated. Right? Programmatically, you can choose either one of them. But now let's take a little bit higher level, let's say design, which is not exactly within the scope for this course. This course, we're still trying to teach you about programming. Let's say go a little bit higher. When you talk about design, the principle would be, number one, you shouldn't catch that right away here, because the fact that the callee actually has some error, you should signal the error to the caller to say, you shouldn't really give me a negative value, at least, right? At least it should be propagated to the first caller, number one. Number two, the principle would be, you don't really want to propagate the exception for too long along the way. You want to somehow handle that somehow in the appropriate timing. But what exactly should be the appropriate timing, there's no right or wrong answer. So that would be something you have to justify as a designer.
So let's say like we have 10 methods, so not the first one, not the last one.
Okay?
Somewhere between.
Somewhere between, of course, now whether that should be number 2, number 3, all the way to number 9 is exactly something you got to justify as a designer, right? Yeah. So I think for lab number 2, we kind of make that design decision for you already. So given the hints in your lab number 2, you would know where you should really catch or maybe specify the exception. Right. All right, guys, any other questions? Okay, so please do think about the exception here. It's tricky if you've learned it the first time, but we just keep discussing it, all right? Okay, so that's a diagram, and we did last time. Okay, so today, I would like to do definitely finish off the exceptions lecture. So this one here might be a nice review, kind of relevant to what you guys were kind of asking, right? But this is still like a programming. So I just wanted to review about how the execution flow is going to occur at the runtime. So I actually got 4 cases to talk about, right? So these 4 cases summarize about what you should really watch out for when you study exception. Okay, let me just go over what the 4 cases are, and then we'll dive into detail. So let's say we're calling some method called m. Let's say O.m over here, and we're calling O.m. And here, we're calling O.m as also O.m. Let's say the method m specifies some exception, whatever exception it is, some exception. So now, the caller of this particular method has the option to either catch or specify. Okay? So on this particular page, we choose to catch. That's why you see a try and catch block and try and catch block around. Okay? So these 2 scenarios we're going to talk about, because the exception may not occur all the time. When the value is, for example, is negative, then exception occur. When the value is not negative, it does not occur. So you got like a binary choices, right? So when the caller uses a try and catch block, the exception may either occur or not occur. Okay? Versus if the caller tries to simply specify the exception. Again, we got a binary choice. Either the exception did not occur or occur. So we're going to talk about these 4 cases. Okay, just review. Okay? Let's see. Let's say we talk about 2 scenarios where the caller chooses to catch the exception. Okay, so let's now be very clear about what's happening here. Let's say the input value for O.m this time is such that when I say normal, normal simply means it's not interrupted by the exception being thrown. So in this case, the exception is not thrown. The exception is not thrown. And then this one here will be abnormal. Abnormal simply means the execution flow is disrupted, okay, by the exception. So this one here is where the exception is thrown. Okay, so just notice that I talk about abnormal versus normal. Okay, let's see for each one of them how the execution flow is going to flow, right? So let's do the label, okay, and then we'll compare and contrast. Let's say talk about the normal flow, okay? So we're going to start with whatever that goes before the try block. There might be just variable assignment, creating some object, etc., right? Just before that, so number 1. And number 2, we should really go into the try block and then try the very first line. So I'm going to put this method call here, number 2, right? And we said earlier, whether or not you should really go to the next line from this method call depends on if the flow is interrupted or disrupted by the exception. In this case, the exception was not thrown. That means you can proceed to the next line. Okay? So that means you will go for number 3 right here. And number 3 here already reached the end of the try block, right? If you already reached to the end of the try block, but you haven't got any exception thrown, because any exception thrown will actually find the matched catch block and go there. But we don't have any exception thrown. So that means all the catch block, in this case only one catch block, is bypassed. Okay, so when I say cross, means bypassed. You don't even go there. So what you go is, you can think about the whole try and catch statement is done. So outside of that, we still got some lines of code right here. So that would be number 4. So basically we're saying before and after the try and catch block, the code must be executed. And also if the method call did not throw any exception, in that case, we'll simply go to the next line. All right? So that's scenario number 1. Okay? Let's look at scenario number 2 in parallel. The first few steps or first couple of steps will be identical. We still have to execute before the try block, and then we got to go into the try block and then execute the method call. But now this time we assume that the method call is going to throw that exception. That means the flow will be disrupted. If that's disrupted, we're going to bypass the rest of the try block. And then we need to find out what the runtime, right? The runtime is going to find out which catch block can catch that particular exception. Since we assume it's going to be some exception, so some exception is going to match. So we go to the catch block and then execute whatever that's inside. Number 3. And notice that number 3 here, even though I only put a single label, but it can be arbitrarily complicated code you can write over here. But typically it wouldn't be that complicated, but we'll see some example today. Okay? So after number 3, basically catch block is done. So we're going to execute the rest of the code right here. All right, so let's now do some comparison. What do they share in common? They share in common, for example, number 1 here, number 1 here. And also the method call here. Okay, let me just say the method call here, the method call here. And then outside the try and catch block, outside the try and catch block. So this is what they are in common. What they are really different is about, this case, we'll proceed to the next line. In this case, we'll bypass and go to the catch block. So the pink ones really highlight the difference between normal versus abnormal flow. Okay, is it clear? Okay. So let me just make one more note for you, and then we can move on to the next 2 scenarios. So you can think about this part over here. We say that bypass the catch block because no exception occurred. Okay. On the other hand, what we bypass in the second scenario is a different part. We bypass the rest of the try block. Right? So here you can think about the rest of the try block bypassed because exception occur. Exception occur. All right? So these are the 2 scenarios. Okay, think about it. Okay. Now let's go to the next 2 scenarios. So these 2 scenarios here where the caller try to do a try and catch block. Let's say they choose to specify. Okay. So you can see that we got a specify option here. So throws and throws. And then we'll see how exactly the execution flow should go. Right? So let's make some assumption here. For this scenario here, the exception did not occur. The exception did not occur. Versus the method throws that exception. In that way, the exception was thrown. Apparently, the flow will be disrupted on the right, but not on the left. Okay, let's see. This time, let me just try to kind of execute these 2 blocks of code in parallel so you can see more clearly. Okay, what would they share in common? So anything before the method call will be just the same, right? So we're going to have something like this. So number 1 here, number 1 here, number 2 here, number 2 here, number 3 here, number 3 here, and number 4 here, and number 4 here. Up to number 4, just the same. The difference is going to happen starting from line number 4. From line number 4, we call this method here, and no exception occur. So the flow should not be disrupted. So go to the next line. In that way, we're going to just number 5 and number 6. And then we're done with M1. On the other hand, this one here, because the exception actually occur. So that means from this point over here, the exception will be thrown to whoever is calling C1.M1. Exception disrupted the flow and thrown to the caller of C1.M1. And C1.M1 is the current method. Okay, let me visualize this one to you a little bit, but that's something you really already know, but I just want to make it more explicit. Let's use a call stack to see what's going on over here. You can see, let's say this is a call stack. Oh, sorry. Okay. Let's see what's happening here. Let's first of all think about what do we know. C1.M1 is the caller. And then the callee is C2.M, right? That's something I'm pretty sure you agree. And that one there would be C2.M. That's a callee, right? So how do you position these two methods on the call stack? The caller should go below the callee, right? That's something we know. So what we have is C1.M1 calls C2.M. And we might have some methods that call C1.M1 underneath it, right? How many methods? We don't know, based on the context, okay? So what's happening here is C2.M over here throws some exception. And that one there actually will specify it. So that means this exception here will be thrown over here, specify. And C1.M1 also chooses to specify as well. So this is why I said somehow this exception is simply thrown to the next method, which calls C1.M1, right? The caller. All right, so that's how you can see how things are going. Okay. So you can think about, let me just make it a little bit more precise for you on this diagram. So it's simply thrown to a method, right? We don't know what that method is, but that method was the one that calls C1.M1. Okay, like that. Okay, of course, there might be more methods underneath it in the stack, right? Not necessarily we're at the bottom. All right, I would say maybe the last scenario is slightly, well, it's not difficult when you look at the flow because you just ended right here, just got interrupted. But somehow to see exactly what the context is, you will need to visualize the stack for yourself. All right? All right, any questions? All good? All right. So that's more like a review about a different scenario, and now I would like to do some tracing together with you, okay? So again, this tracing here does require some patience, but I'll try to be as thorough as possible, okay? So this is something I briefly mentioned on Tuesday, right? So we just want to do it thoroughly, okay? This will be version number 2, which is much harder to trace, which I would like to do with you. And version number 1 has no loop. In that case, I'll leave the page clean for you. You can try that out after the class. Okay, let's try this one together. Okay, quick reminder. We have the circle class. We got some attribute called radius. And we have the set radius method, which will take some value. And that one there specifies some exception. It's called invalid radius exception. May or may not throw that exception. When the input parameter r is negative, we throw that exception. Otherwise, we're going to use that value to change the current radius, right? Very standard, right? Either there's an error or there's not an error. And then whenever you call get area, you're just going to use the radius value to calculate, right? Simple class. And then we got a class here, the caller. Circle calculator number 2. And then we got a main method here, right? The entry point of execution. So we are using an input scanner. I think you saw that maybe in lab 0 part 1, right? This one just a way for the user to enter something from the keyboard, okay? So I'll talk about how exactly to use this Boolean variable, but let's just wait for that. And notice that there's an exclamation mark, means negation, right? False to true, true to false. We'll see exactly how this will turn out to be, okay? And then the program always is going to prompt the user to say, now enter me a radius value. And the user is going to enter some value that can be treated as double. It can be 2.3, 23.69, whatever, right? However, if the user enters something that's negative, that should be somehow rejected by the program. It should not be used as a radius. We'll see how exactly this can be rejected. If the user keep entering something that's negative, the program is not going to give up. It will just keep prompting the user to enter another number until the user decides to give some valid integer number that's non-negative, right? So what I want you to really look at when I do the tracing is to think about the following. This method here potentially may throw the invalid radius exception, right? So based on what we just reviewed, from this method here, we may either go to the next line if the exception did not occur, or we might actually got disrupted because some exception occurred, and we simply go to the catch block that will catches the invalid radius exception. So there are two possible execution flows, right? That's something we just talked about 5 minutes ago, right? So you really want to make sure this one is followed, right? I'm just repeating the same pattern, okay? All right, let's now see how we can trace it. Let's make the following assumption. Let's say the user, the first time, is going to enter -5, which will be somehow rejected by the program. And the program is going to prompt the user to enter another number. And the second time, the user is going to enter 10. And that should be accepted as a radius. And then we'll print out the area accordingly. Okay, so that'll be the setup. And I'm just going to see how, okay, the best way to do this would be like this. So let me put a console output here, right? We're going to write down exactly what the output is going to be like. Okay, so this will be the console right here. Okay, and then we also have a call stack. And the call stack here, I can write it out just right away. It's quite easy to see because there are only two methods here. So we got circle calculator 2 and also the main. So that'll be entry point of execution, circle calculator 2 dot main, and which we'll call the circle dot set radius. You can see the set radius is called exactly right here, right? So that'll be circle dot set radius. All right, very simple method call. So not even 3, just 2. So let's now trace the code line by line, also label the flow. Okay, that's so important. Let me start with the program. We declare some scanner, number 1. And then we're using this particular Boolean variable. Let me just visualize it right away. So this Boolean variable here is called input radius is valid. Input radius is valid. Initially, it is not valid, let's say. So we initialize that to be false. Okay. And then we're going to go for number 3. Number 3 here is going to check for the while loop. If you recall, maybe from the first year, when we first check the Boolean condition for the while loop, if that one is true, that means we're going to go for the very first iteration. It's going to keep repeating the pattern for the body of the loop until the Boolean condition becomes false. Right? That's a meaning for the while loop. So now, for the very first time, not this variable, not false, which will be true. So we go in there for the very first time. Okay? So we're going to go for number 4 here. That one there is going to print out, enter a radius. Enter a radius. All right. And then number 5 over here is going to prompt the user for some double value. And we assume the user is going to enter -5, right? So they're going to enter from the keyboard -5. So that means the R value over here is going to be -5 right now. Okay? And then we're going to go for number 6. We create some circle objects. In this case, you don't really need to draw the box for the circle. It's not necessary for the tracing purpose. But in some cases, maybe you have to. But in this case, you don't need to. Okay? And then we're going to go into the try block. Right? The very first line will be set radius. Okay? So I'm going to go for number 7. So number 7 will be the method call, which we know may or may not throw that invalid radius exception. So now, whether or not we should really go to the next line here depends on whether or not the flow over here will be disrupted by the invalid radius exception. So let's now step into it. So when you step into it, the set radius, which will be right here. And we know that the radius value we are trying is -5, right? -5. So set radius, we got -5 here. And then we try to go for number 8, checking the if condition. -5 less than 0, true. Going to the if, right? So that one there will be number 9. So this one here is going to throw that new exception, right? It's going to throw this exception right here. All right? As soon as the throw new exception is actually executed, that means the set radius method is going to terminate abnormally, right? So think about this line here is going to terminate the set radius method abnormally. And we can simply remove it from the stack. All right? And now the only method that's active in the stack will be the main method. And this is where we actually got suspended. So let's resume from over here. Right? So we know that from this line here, based on the -5, the invalid radius exception is thrown. So we simply just cannot go to the next line. Right? We should really go to the relevant catch block that's going to catch it. Right? There's only one catch block, so it's going to catch it. Right? So that means we're going to go for this catch block over here, and then execute the print line. And that's going to be number 10. You're going to print out, try again. So from the user's point of view, it will simply say, try again. Let me pause for one moment. You can see what's happening here is we are using the try and catch block. And then we nicely use some Boolean variable to allow us to go for the first iteration. And then the catch block will actually just print out try again without throwing the exception directly to the console, right? So it's not like a version 3 where the user will be clueless about what to do, right? So here, that's very important. But at this point here, we're still running the program. The loop is not done yet. All right, any question? Go ahead, please.
When and where are we going to see negative radius? The one you put in.
What do you mean to see it? You mean the user see it, or what do you mean to see it?
Are we going to see it in the console, or?
Okay. So the reason I put this -5 here is simply when we execute this line, when the user actually enter -5, and -5 will be read into the program. And then -5 will be stored into the R right here. And then the -5 will be used to call this method here, set radius. And when we actually call this method here with a -5, because it's less than 0, we can throw that exception. When the exception is actually thrown from this particular method, it's going to bypass the rest of the try block. And then we simply go to the catch block and then print this out. So no one actually sees that -5 really, except when you call that method. The -5 never get printed out.
Okay, good. I understood that, but I'm not talking about the -5. I'm
Mm-hmm.
talking about the negative radius. You see like the string values capturing throw new invalid.
Oh, you mean this one here? Okay, I see what you mean. You can think about, okay, now I see what you mean. This one here is a string value that's kind of passed as part of the attributes of the exception objects. So this string will only be seen if you somehow try to print out the exception. So one line you can write, for example, would be, let's say, well, it's not recommended because it's not kind of relevant to the user. User doesn't want to know too much about this, right? But if you really want to, what you can, remember we got invalid exception here, and then we got E, right? What you can do is, like, you can write a line to say print line, and then E itself. That one is going to include that string message somehow. Mm-hmm. Okay? Yeah, question?
Just wanted to explain the while statement, because the while statement, doesn't that say that while the input radius is valid, but it has the negation?
Mm-hmm.
Wouldn't that
Okay.
mean it's not valid?
Okay. Put it in this way. Okay? When we say like a while, some Boolean condition. Let's review some basics just to be sure 100% understood. Okay? You got some pattern here. The idea is the body of the loop is repeated as long as B here is true. That one we agree. Good. Now the B itself can be arbitrary. Can be like a compound Boolean expression. So now B itself may be something like not, let's say, C, for example. Let's see, it's another Boolean variable. If B itself is declared as not C, what does that mean? That means the body here is going to be repeated as long as C is false. The reason that they are completely true and false simply because of the negation I put here. Can I follow so far? Okay, so now that's something about the logic. So we got to make sure the C here is more like this Boolean variable right here. We want to make sure if it's time to really exit from the loop, we're going to set this Boolean variable to be true, so that not true is going to be false, so we can exit from the loop. Okay, that's really the trick. Okay, and of course the name itself is kind of up to you, like how you want to name the variable. I kind of name it to be input radius is valid. Initially just false. As soon as the user enters something as valid, I'm going to set a valid Boolean variable to be true. Stop the whole thing. Yeah, we're going to see exactly how that's going to happen. Right? All right. Any other questions? Yeah.
If an exception, is there a way to see where it came from? For example, if I do the set radius multiple times, can I know which function the set radius came from or which method? For example, if I do set radius for S1 and set radius for S2, can I know which?
I don't think so. I think the only information you can know about the exception, because as soon as let's say you call the set radius multiple times, it depends on which is the first one that triggered this exception. The very first one is going to be somehow thrown and it has to be handled, right? So the only information it can include is in this particular string value when you first create the exception. That's the only thing. But you don't really have any outside context you will know. Yeah, that'll just make things way too complicated. All right. All right, let's now move on, okay? Good questions, guys. Keep going, okay? So now we are here, number 10. So now what should we do? We basically have finished executing the try and catch statement here. So we're now reaching the end of the while loop. What we should do is we should go back to the header of the while loop, check to see, should we go for the second iteration, right? So what we do is, let me change the color. So now I'm going to go for 11. So 11 is going to be the while loop, okay? I'll just put 11 here, okay, 11. 11 is checking this while loop right here. All right, so now the value for the Boolean variable remain to be false. So not false will still be true. So I still want to go for the second iteration, which makes sense because the value user just entered is not valid. I want to prompt them again. And then I'm going to go for 12 over here. Enter a radius. Okay, so from the user's point of view, they will say enter a radius. And then we're going to execute the next double method again, right here. And we assume that the user is going to enter 10, right? So R is going to store 10 instead, right here, okay? So that'll be 13. And then 14, we're going to create another local variable for the circle. And then we're going to go into the try block. So that'll be 15. 15 will be the method call right here. So this time we're calling that with the value 10. Okay? Whether or not we should really go to the next line depends on whether or not this particular call for set radius on 10 is going to throw that exception. We're going to find out. Okay? So we're going to go to step into the method call right here, set radius. And then this time we got the value 10. Okay? So now we're going to execute. So this will be 10. And then we got 16. 16 will be checking to see whether or not this if statement, the condition will be true or false, right? So we got 10 less than 0, false, right? So we go into the else part. So that will be 17. Okay, 17 will be to set a radius to be whatever value it is. Okay, let me omit that particular visualization. We just set it to be some value, to be 10. So after 17, we have basically reached the end of the else statement. So the if else is done. And because if else is the only statement for this method here, so this method here is going to terminate normally. Okay, it is important for you to know that this one here is going to terminate set radius method normally as opposed to abnormally. So you can think about we're going to remove that method from the stack, right? If we kind of do the method call. So if we remove it, we're going to execute where we got suspended, which is right here, right? Set radius. So that one there is going to be 18. Oh, beg your pardon. Let me say it again. So we go back to the set radius over here, which was suspended. So now, because the exception was not thrown, I'll make a note. This one here, input radius exception not thrown. So we should be able to proceed without being disrupted. So now, watch out. We're going to say 18 will be right here. Remember, we got 17 here, and then we got 18, right? So we are now able to go in here. All right? So when we actually go in here, we're going to set the input radius, this Boolean flag, to be true. This is so critical. All right? And then 19 and 20 is simply just to actually print out the area. That one, you can just imagine how that's going to be. Of course, the user will enter just 10, right? That's what you will see in the console. And then afterwards, you will see that like an area is whatever, right? That's what you will see. So when we actually go up to 20, so we are now done with the try block. And because no exception has been thrown, catch block is completely bypassed. And now we have reached the end of the second iteration. And then what we should do is we should really go back to the while loop. So I'm going to say that's now 21. So 21, we are checking this while loop one more time. So now input radius is valid, has been set to true. Not true is going to be false. Exit from the loop. So there are 2 iterations in total. For the very first iteration, the user enters something that's not valid and triggers the exception. So we don't really change the Boolean variable, and we keep going for the second iteration. In the second iteration, the user enters some valid value for radius, which is 10. And in that case, the exception was not triggered, in which case we proceed to this particular line right here to set a Boolean flag to be true. In that case, we're going to cause the loop to terminate. Right? So this thing here will not run indefinitely. All right? Not trivial, but hopefully you kind of get an idea. So what I would suggest is try this out also to trace by yourself to see exactly how things are going to happen. Right? So if you like, I would suggest a little bit more complication, slightly more. You may want to try 2 test cases. Exercise 1. Okay? What if you simply got enter 23? Just get it right for the first time. That one should be easy to just for you to warm up. Exercise 2. Slightly more extended than what we are doing here. It could be that you do -4 and then -3 followed by 10. So there should be 3 iterations in total, but you want to see exactly how the Boolean variables and etc. will be modified, right? All right, question? All good? I'll go one by one. Go ahead first.
So on our test, will we be tracing also? Like how you
You can definitely expect like a tracing question of this kind of complexity, but exactly how I'm going to ask you, maybe may not be exactly like a label, like a line like this. I might say, for example, I might label each line. For example, like a line number 1, line number 2 for each method, and it kind of ask you to really tell me the sequence of the lines that's going to be executed. You will see some example question when I give you a practice question for written test 1. Yeah, you will see some idea. Yeah, go ahead.
If we didn't do any try or catch.
You mean hypothetically, if we didn't do any try catch?
Yeah.
Good question. Okay. Good question here. Let's play that out, right? Let's say here, if I didn't have the try and catch, let's say, so that means the main method here must specify it. Agree? Okay, let's go for that scenario. In that case, when the user first enter -5. This line here, set radius, is actually going to throw that exception. And that exception is simply going to be thrown directly to the console. That means something like this. After the user enters -5, rather than usefully ask them to try again and prompt them again, you're simply going to throw the exception directly to them. And the program is done.
So that's an error.
Huh?
That's an error?
That's, I would say that one, just the program behavior. That's what you chose to be, right? Because you didn't choose to try and catch that exception if you choose to specify it. So now, whether that's a good design or not, I don't think that's a good design. Because you should have been able to prompt the user to try again. But since you specified the exception, you're just going to throw directly to the user. The user, what can they do about it, right? Yeah.
And the program terminates there? Or
Yeah, as soon as the exception is thrown to the console, that's it. Yeah, because the call stack will be empty, right? Yeah. All right, guys, how about we do something very quickly, just 2 or 3 minutes, and then we'll take a short break. Okay, just one more thing. Okay. So version number 1 about the circle is very easy. You can take a look just to make sure you can trace it. I do give you some suggestion about the test cases. Give it a try to see how you can label the code for flow. There's another example on your slides. That one is not very complicated. It just involves 3 classes. But I do want to point out one thing to really show to you. Okay? Let's say the following. We actually got some exception here called invalid transaction exception. Let's say when you want to withdraw some money from the account, the amount to withdraw better not be negative, right? Got to be positive. So how do we program that exception here? So let's say we got account class, and we got a method called withdraw. And this is where the exception may be originated. So that's why we specify it, right? Easy. The second class we have right here is called bank. And then we got another method called withdraw. And notice one thing here. The same method name, withdraw, happens in 2 different classes. So that's why when you talk about caller and callee, you better specify the class name, right? That's one thing to show to you. And then we have another class here, bank application, and then the main method, right? So these are the 3 methods we have, okay? So let's now just work backwards quickly. So you can see right here, in the bank application.main method here, we actually call withdraw. And the withdraw method comes from B, which was declared as bank, right? So you can see that if you want to build a call stack, let's do it together just for that one. So you got bank application dot main, which calls the bank dot withdraw. So far, so good. I want to talk about just one line. Just make sure you're comfortable with it. Let's look at this line. Okay, I'm going to write it besides. That one there is something called accounts I dot withdraw. And then pass something over here, right? This might be something you already did, maybe in your lab number 1. I'm not exactly sure. Maybe you have, right? But this one is not difficult, but I want to make sure you know how to figure that out. We have a method called withdraw. That's the call. That's the method being called, callee. But what will be the context class for this? That's my question. Because this one looks like array indexing. How do we figure that out? If I want to somehow, well, you can see from bank.withdraw, we're calling this line. So I should really put something.withdraw. But what should be this class? That's my question. Based on this class over here. What should I put? I heard account. Anyone else? If you think this should be account, which line did you look at? To figure out this one should be account. Yeah, exactly, right here, right? So you can see this line here, we declare accounts to be an array of account. And if you think about this part here, based on the declaration, is of type account array. Oh, sorry, let me do it again. Just this variable alone is of type account array. And then we have right here indexing into the array. It's going to be individual element. So that one there is going to be account. Right? You can see if I only look at the accounts itself, it's an array. But only go to some indexing in there, it's going to be account itself, right? So that's why this one should be account. So I should really put account right here. You got to be careful because they're both withdraw, but from different classes. All right? That's something you got to watch out for. Okay? All right, question about this one here. Okay, this one here is not difficult. You know, I kind of explained the trickiest line to you. You can definitely try maybe some negative value over here to withdraw and see what's going to happen. It'd be very similar to what we did earlier, but I'll suggest you also try this one here. If no question, why don't we take a short break for 3 minutes and then we can talk about more example. Okay, get your iClicker ready, please. We got 2 more examples to talk about for exceptions. Let's go over them, right? Just make sure we finish the exceptions lecture properly, and then I think we should still be able to do a little bit about the new lecture, just some introduction stuff. I think that should be good. Okay, we'll see. We'll get about 24 minutes-ish. Okay, so example here, this one kind of shows to you the following. Where you actually got a try block, and you're making more than one method call, and each one of them might be able to throw different kinds of exception. For example, for this one here, withdraw, which is in the bank example that we spoke about, this one might throw the invalid transaction exception. Okay? And this one, I would say may, okay? Which means may or may not. Okay? And this one here, which we're also very familiar with, the set radius method. This may throw the negative radius exception. Okay? So basically we got 2 different lines of method call. Each one of them may or may not throw some exception. And these 2 exceptions are different types, just 2 different exception classes, right? They happen to be put in the same try block. The requirement is for each one of them, you must have the associated catch block to catch it, just in case the exception occur. All right, so you can see one catch block over here is about negative radius exception, which might be thrown from here. And also another catch block here is about invalid transaction exception, which is to deal with if the exception is thrown from over here. And one thing to, let me just say one thing here, and then I'll get to you. And the one thing here is, you might be wondering, that withdraw comes before radius. Should we actually get the invalid transaction exception before this? The answer is no. Okay? We're making some assumption. Okay, I'll write it down. Any exception class you're creating following the way we kind of talked about in the class, doesn't matter the order of putting them in the catch block, because by definition, they are not related to each other. So it doesn't matter which one you put. You can put, let's say you got 5 different exceptions that might be thrown from the try block. You can put in any order you like. Okay? There is some complexity that that's something to do with the inheritance, right? Which maybe I wouldn't talk about it now to confuse you. So I would say any exception you're going to put in the catch block should be some exception class you created by yourself, like the way we talk about, right? So let me write down the assumption. Okay. So the assumption goes like this. All the exceptions, you kind of, let me write it down. So the assumption. Okay, very important assumption. The customized exception. When I say customized, basically the ones you create by yourself, right? Customized exception are unrelated to each other. Meaning that they're there, sorry, I cannot write properly. Their catch block can be arranged in any order. Can be arranged in any order. Okay. For example, in this one here, if you simply say you want to swap the order of these 2 catch block, that will be okay. So maybe you want to put the green one first, followed by the red one. Well, want to put the red one first, be followed by the green one. Doesn't matter. They work the same way. Okay? So let's now try to trace this try and catch block. Very easy to see, right? I'll do one test case, and then you can do the other one by yourself. Let's say we are trying this one here. Okay? Let's say we got, let's say test case 2. I actually did section B, for test case 1. Let's do test case 2. Doesn't matter, okay? Let's say we'll do test case 2. Let's say this one here. You can do test case 1 by yourself, okay? Very easy. Let's say the user will somehow set the value for the amount to withdraw to be 100. And then the radius is -5. Right? So 2 values over here. We can set it up. But if you want to read from the user, from the keyboard, that's fine too. Right? Let's say we set a value right here. So let's look at the execution flow. Number 1, number 2, and then just set the variables. Number 3 will be create a bank objects. And then we add a bank account, and we try to do the deposit. So 1, 2, 3, 4, 5 are all fine. We don't need to create the object. We don't need to visualize the object. And then, for number 6, that one there is going to pass 100. 100 is larger than 0, so we know that this ITE over here will not be thrown in this particular case. Meaning that we can go to the next line without being disrupted. So we can go to number 7. And the circle here is going to be created, and then we're going to go to number 8. All right? When we go to number 8, we're going to pass the value for R, which is -5. That one there we know it is going to trigger the negative radius exception. In this case, it will be thrown. That means the rest of the the rest of the try block will be bypassed. And now, which catch block should we go? Right? That's the question. Because the negative radius exception has been thrown, we want to find something that will match. It will only match this one here. Right? So we go there. One, you can think about conceptually, once a particular catch block is matched, you can think about the rest is not going to be executed at all. So you can think about the rest is simply bypassed, like that. And then we're just going to go for number 9 over here, which is going to print out something about a negative radius, and then number 10. Okay, so 10. Oh, right, so that'll be execution flow. And you can give a try on this one here to see what's going to happen. Question? Okay? Yes?
If we call a method from another function, if we call a method from another class that we didn't create, should we check the method, whatever exception it throws, or just use the superclass exception?
Can you say that again? I'm not sure exactly what I'm catching.
If we call a method from another class which we didn't create, should we check the exception that that method throws and then
Okay,
use the
I see what you mean.
use the superclass exception?
Are you asking, okay, let's say I'm using a method from somebody else. Should I check to see whether that method created by somebody else will throw some exception so I should be aware of?
Yeah, that and like the type
Which one
exactly.
should they check?
Yeah.
Mhm.
So
Just check exception generally. Checks.
Right.
Exception.
Yeah, so first of all, let's think in this way. Whenever, let's say Java library, right, which we'll see actually in just one moment. Let's say you're using a method from Java library. Let's say you didn't look at the API, just want to call the method. Let's say as soon as you say some objects method m. As soon as you are done with this, you got some red underline saying that some particular exception is unhandled. As soon as you see that line, you will know that, oh, this method here specifies certain exception you must handle. In that case, you can either specify it or you can try and catch it. So you have no way around. You have to choose one. Mm-hmm.
Should we check that exact type of method, exact type of exception?
You should. Yes, you should.
Use the superclass.
Okay, it's a good question here, but I wouldn't want to. I know exactly what you mean. We wouldn't want to go to that superclass, area because most of your fellow students haven't learned about inheritance. So let's not go there. But I would say any exception you might be aware, it might be thrown from a particular method. Just spell it out exactly. That's good for now. Yeah. Of course, in the most general way, you can just have one single catch block and you just say catch exception. But it's not going to be very useful because you want to have as many catch blocks as you can to say, I only want to deal with a particular exception in this particular catch block, right? Good. So guys, one more example. This one will be interesting, okay? So let's see this one here. Let's see. There we go. Okay. So we are done with this one here with multiple catch blocks. This one here. Let's say this is a method that's in the Java API, right? That's in the integer class. So there is a static method. As soon as you see the word static, as we reviewed earlier, that means you can simply say integer, the class name, dot parseInt, the method name. We know that, right? And the parseInt takes some input parameter of type string, returns something like an integer, takes a string, return the integer, and it specifies an exception. Throws is something called number format exception. Okay? So we're going to see how we can play with this exception here. We'll see. Let's see how we can use it. If you call integer.parseInt, you got to pass a string value, right? So here the string literal simply contains the value 23. So this is somehow called convertible. You can convert this string here into the integer value 23. So this is the normal case where the number format exception did not occur. On the other hand, if I try this one here, the string I put is simply like this. Even though you spelled it out like 23, no, it wouldn't accept it. It will give you the number format exception. Or if I pass maybe the crow Alan, it will also give you number format exception. If I pass the maybe crow, I don't know, LSB, it also give you number format exception, right? So you gotta give a string that can be directly converted into an integer, okay? So that's the rule. Given this, we basically want to write a program. Somehow it's gonna prompt the user for some string from the keyboard. As long as the user enters something that cannot be converted into an integer, we're gonna keep prompting them until they actually give us maybe 23. So it will return 23. That's a program we want to write. And this one sounds just like this radius example we did, right? Version 2. The user is going to keep entering the radius value. Maybe they keep entering something that's negative, but until they enter the positive value, we're going to keep prompting them, keep reminding them. Similar. All right? Let's take a look at this one here, right? That one, you can think about how you might implement it, but I'll just give you the solution right away, and let's go over that quickly too. The logic will be very similar, basically the same. Okay, let's take a look. We have some Boolean variable here. I just call that valid integer. And then we have some condition here, right? Not the case, valid integer. And then we say that valid integer will be assigned to true. As soon as it becomes true, not true is going to be false. We exit from the loop, right? The same logic as before. Let's now try to see what's going to happen. And we assume that user is going to enter something that cannot be converted into integer, and then they're going to enter 23, let's say. Okay? Let's now trace the code. So first of all, we create a scanner, and then we initialize the Boolean variable to be false. I can put it here. So that's the valid integer. Initially, it's simply just false. Number 3, we're going to check to see whether we should go into loop for the first time. In this case, not false, true. Go into loop. So number 4, we're going to say enter an integer. Enter an integer. And the user is going to enter something, right? We assume that they're going to enter 23. They're going to enter 23. So the user input is now going to store 23 as a string. So when we go to the try block, let's say this is number, okay. So this one here, of course, is number 5. And then we try this one here. So the user integer is now 23, the string being passed. What's going to happen to this line here when we call that? Is it going to give us an exception? It should, right? Because 23 here cannot be converted into integer 23. So we can expect number format exception thrown. Meaning that we're going to bypass the rest of the try block and go directly to the catch block, which will match the number format exception right here, right? And then we're going to say this is not valid, okay? You're going to see something like a not valid. And let them try again. So after 7, we are reaching the end of the loop. And we're going to check the while condition once more, right? So this will be number 8. Okay? Not false. True. Second iteration. And then number 9, enter an integer. Enter an integer. And then number 10, the user is going to enter 23. That means the user input this time is going to be 23. Okay? So when we get to 11, making the method call right here for the second time. It's like that. Calling the same method. But now this time, are we going to get number format exception? Not really, because 23 is a quote. In the quote can be converted into the integer, right? So that means the user integer this time is going to store 23. And then we will be able to go to the next line, 12. And the rest of the catch block will be bypassed, right? It's exactly this two different execution flow. After 12, we go to the end of the loop. And we're going to check this one more time. Right? Oh, by the way, you will actually set this one to be true, right? All right. So go to the end of the loop, and we are going to check this one here the final time. So this will be 13. Okay, I'm running out of space, but 13 is checking this one for the final time. So not true, false, exit from the loop. Right? So this one worked just like the radius example. But this one here is also very useful. Somehow you want to read some value from the user that can be turned into integer, right? Just by using the library method, right? But here what we're using is really about a method may or may not throw certain exception. When you want to catch it or not to catch it, right? You want to use this kind of logic here. All right, any questions? All good? Yes, please.
Explain how the computer determines whether something is a string or like an integer here when you put in like when you put 23 in words.
Right.
How does it know that it has to be an exception?
So, of course, that's really up to how the library method is implemented, right? So when you look at these two strings, right? This is a string with the character 2 followed by 3. And this is a string with T, W, E, and T, Y, etc. So these are two different strings. Somehow the method parseInt has a way to figure out whether the characters you're entering here really correspond to an integer. For us to see it is kind of obvious. But when computer work with it, you got to work on the string. Yeah, so it's different. Yeah. So parseInt actually is quite a useful method to use. You might see some use of it, maybe outside this course as well.
ParseInt determines like whether something is
Whether a string value here can be converted into an integer. I think you can also look into it. I think this is the class called double. And double got something called parse double, which will work in a very similar way. Yeah, I can look into it as well. All right. So we are done with the exception lecture. So we got about 7 minutes. I think we can do something here. Okay. I want to just introduce quickly the example we're going to use next week for the J unit lecture. So now we're completely done with the exceptions lecture. Please make sure you follow through the slide. There are certain things we didn't really say in the class. You should really study them as well for completeness. All right, so this lecture here, we'll talk about test-driven development and also JUnits. I'll talk about it, especially I'll show you a flow chart you really want to somehow follow, maybe for your subsequent labs. It's a very good practice for you to actually follow. Okay, so let's see. We're going to talk about several things. We're going to have some bounded counter problem. Okay, a very simple one, I'll talk about it. And also deriving test cases. And also talk about normal versus abnormal execution flow. We're going to use these two concepts again to design good tests. That's something we'll see next week as well. right? And also exception, okay? Especially exception. We're going to see some very nice use cases for exception as well here. All right, good. And also regression testing. That's something I kind of mentioned on day one when we walk through the syllabus, but I'm going to talk about regression testing as well so that you can apply. All right. So let me just go directly to the background for the counter quickly. Okay, and then we'll draw some diagram together. I'll get to these two maybe next time. It's just a review of the catch we'll specify. We don't need to talk about it now. Let's say we got a counter class. A counter class has two. Final, you may have seen that maybe in first year. Whenever you use a final keyword in Java, simply means your variable is a constant. Once you initialize it, you cannot change it. It always stays the same value. Usually it's for defining something that wouldn't change. So we have the counter value being maximum 3, minimum 0. All right? Combining these two together, we know that the range of the values that will be allowed for the counter should be 0, 1, 2, 3. Right? 0, 1, 2, and 3. Okay? So one is called a minimum, the other one is called a maximum. Right? So these two are the constant. And we have the value here about the counter. We can also get a value. Okay? And also initialize the value to be the minimum. So think about the 0 here is the initial value. Okay? Of course, it may go all the way to 3, at which point you should not be allowed to increment any further. Okay? So now, here's the thing. We got only two methods that's public for us to run. One is called increment, which will simply increment the value by 1. We got another method called decrement. And the decrement method is going to decrement the value of obviously by 1. Okay? So now, you can look at the condition over here a little bit later. Okay? You can look at that just to convince yourself. The condition here and the condition here, right? But the idea goes like this. I should be allowed to increment from 0 to 1, and 1 to 2, and 2 to 3. If the current value is already 3, the maximum, I should not be allowed to go from 3 to 4, because in that way I'll go above the maximum. So if I try to increment when the value is already maximum, what I should do is throw some new exception to say the value currently is too large. You just cannot do it. All right? On the other hand, if I can decrement from 3 to 2, 2 to 1, and 1 to 0, if the current value is already the minimum, I cannot really decrement further to -1. That will be below the minimum. In that way, I should really throw some exception called value too small exception. So there are two possible exceptions we are expecting in different scenario. Okay, just notice that one is called value too large, the other one is called value too small, right? Two possible exceptions. Okay? So that's about the context you should know for this example here. But let me do one more thing. I got 3 minutes. Let's see how much I can do. Okay? If I cannot finish it, we'll continue. Let's see. So this is a diagram called a state diagram. It's a very nice way to really show what kind of test cases you can derive for your application. Because we've got a very simple counter here, we can derive exactly the number of test cases that will thoroughly test the program. Quick question for you, just before I start talking about it. Given that the counter value can either be 0, 1, 2, and 3. These are the 4 values. I know that I can either do increment or decrement. I can also expect to see value too large or value too small exceptions at some certain point. How many test cases do I need in total to thoroughly test this application? Give me a number. How many? Thoroughly. I heard 3, okay. 4. More than that. More. 8. Let's see. All right. Initial value is 0. Initial value is 0. Of course, this could be one extra test case just to make sure initial value is 0. Let's not worry about it. Okay. Now, for every value for the counter, you want to think about what if I do increment? What if I do decrements? Each one of them should be a separate test case. Okay? If value here is 0, I can do increment. When value is equal to 1, I can also do increments. When value is equal to 2, I can also do increments. When value is equal to 3, I should not be able to do increment. Agree? That would be too large. Also, when value is equal to 3, I should be able to do decrements from 3 to 2. And when e is equal to 2, I should be able to do decrement to go from 2 to 1. I should be able to do another decrement here. So you can think about each one of them is a separate test case. We got 6 already. You can think about these 6 test cases are the ones I don't expect to see any exception. All right? And then, what are the 2 other test cases I should really test as well? Let's say I do here. If right here I try increments, I should expect to see value too large exception. On the other hand, if I try to do decrements right here, I should really see the value too small exception. Okay? Give me 1 minute, and then I'll let you go, please. So this diagram here really shows up for this particular small rectangular example. We need 1, 2, 3, 4, 5, 6, 7, 8 test cases. However, we'll talk about from Tuesday. There are 2 kinds of test cases. This kind over here, you do not expect to see any exception. However, for the other kind, you do expect to see some kind of exception. So the way you're going to set up the test will be completely the opposite. We're going to see exactly how you would do it. Thank you so much. You can join the review session tomorrow, but if not, make sure you do your lab number 2. All right? See you later.